Alright, well, welcome to Amplifier 208. What we got here is an amplifier kit from Amazon. It's a 2.1 channel audio amp. It's a DX2.1. It is a 2-channel amplifier with a subwoofer output. Comes back here. Got a cooling fan. I installed this here temperature sensor. It's an N-channel MOSFET. It's got the temperature sensor here. So the hotter it gets, faster it spins. Anyway, so here's what we got going on. When I purchased this amplifier, it was extremely damaged. You can see here on the heatsink there that it has been hit and struck. When I first got it, this volume potentiometer here was broken, as you can see there. It's 50K pot. It was smashed and it was bent in. I'll also throw some pictures up in the video. You can see that. And the box that it came in over here, which you can see is really damaged. I literally think they threw it over from China. I don't even think it was shipped, because when this box arrived, it was in another box, but the other box was perfectly fine, but this box was destroyed. And the amplifier was, damaged. So, that being said, there's another thing I want to bring up. A lot of these components in here, the pre-drivers here, which are we got an A13 here, 2SA. We have a 2SA 81013, 2SA 1013. That's a PNP. And on this side over here, we have is what you call a 2SD 667A, which is not even the NPN equivalent to this one. The E1013, which is this here PNP, is supposed to have a 2SC 2383 for NPN equivalent, you know, for kind of a pair. But yeah, it's probably what they had in the bunch, so it's kind of what they threw in here. And then we got the pre-driver here for the voltage amplification stage. It is also a 2SA 1013 PNP, which is alright for that. And then we got these here. We got the differential pair, and the diff pair consists of the KTC 3198s. These are TO92 package. These are a TO92L, or bigger package. Okay, and then there's also the output stage, which are nice Sankins. They are a decent set of transistors. They're 8 amps, about 80 watts of dissipation. They are the 2SA C4467s, and they are the PNP is a 2SA 1694, which is good. Those are decent output transistors. And we got a nice here, we got the quad op amp, LM324, I do believe. LM324N quad op amp, that'll be for the input and probably crossovers. That's exactly what that's for. This here is the GRC. See here. GRC 4558D, and that'll be for the subwoofer output. That'll be for the crossover unit for that. Got some 12-volt Zeners. That'll be setting up the plus-minus rails for that. Probably for the quad op amp there too, the LM324. That's another thing I noticed here. You will see there's absolutely no bias adjustment for these outputs. We got 2 pairs here, you got 2 pairs here, and 2 pairs here. These are subwoofers. This is your left and right channel. And the bias is being set up using these 4148 diodes here, and that's setting up the bias for the proper voltage drops for these just to be barely turned on. Now, I have never hooked up a transformer to this yet, because I was doing a lot of measuring and fixing of these components. They were completely, I'll throw up some pictures here. These were all messed up. They were laying on their sides. Their capacitors weren't straight. They were just all over the place. Just looked absolutely freaking terrible. What else can I say about this? Yeah. So there's another thing I wanted to mention. Capacitors are good. These are 50 volts, 6800 microfarad, and they're Secons. Look pretty decent. RCA inputs, pretty basic stuff there. But what I do want to show you is, you'll see the meter here, and we'll go to ground here, because ground is ground all the way around. And if you hit the back of these collectors, oh, look at that, 525 ohms, 525, 525. That one's open, but that's all right. Go to the screws, 586 ohms. Yeah, there's all these transistors, collectors are attached, electrically attached to the heatsink, which that is a big no-no. So right there, if I would have hooked power up to this thing, I would have used my current limiting bulb anyway, but yeah, I would have grenaded and lit that light up like a Christmas tree. So yeah, as you can see there, I go here, and it seems to be the same all around. You can see there's diode drops and the charging capacitors. That's not good. That should be 100% open. That should be an open circuit. That should be infinite. That being said, all right, I'm going to flip this around here. There's another thing I want to show you. And you're going to see on here, you're going to ask yourself. I'm going to get my little pointy. All right, here's the left and right channel here. This is your subwoofer output. This here is what I put in there for the temp sensor, the NTC thermistor. This here is your emitter. Comes around, emitter goes out to here. Here's the emitter here. There's your emitter there. It goes out to there. Here's your feedback circuit that goes in here to your diff pair. All right, what don't you see here? Absolutely zero degeneration emitter resistors. They were gone. They don't exist. None of them, not any one of these, have degeneration emitter resistors, which I've yeah, I've never seen that. It's kind of usually there to help the stability in the bias circuits and thermal tracking, and the maybe the gain of these, the HFE, these transistors may be a little off if they're not matched, and the emitter resistors actually help compensate for that and the bias itself. And another thing I've noticed is the positive and negatives. The positive on this side and the negative on this side are hooked up differently. The negatives are controlled on this side with the emitter resistors off the emitters, and on the subwoofer side it's the opposite way around. The positive is controlled off the emitters, and the negative is just hooked to the negative. Where the other way, it's the positive is hooked to the negative, and the negative is hooked to the positive. Which is right there. This is going to be out of phase with those right off the top, unless it's inverted somehow. But we'll figure that out after. But here's the thing: I'm not going to put power to this because every single one of these collectors is not insulated. Whether it's from the negative voltage or the positive voltage, they're not isolated from the heatsink. So that heatsink is electrically connected to every one of these collectors, which is a big no-no. And when I first got this, The board in the back was just terrible. There is these diodes here. I'm not really sure if you can see it, but you can see it here. And here, these are the diodes that set up the bias spreader for the, right here's your pre-drivers, and it goes in here, and it sets up the bias for those. Here, it goes into there. There's your base of the pre-driver, goes down into your diode. And the diodes go here to here, over to here, and then into the base of the next pre-driver. So that sets up your bias for your output stage. And then they'll go into your diff pairs down here, but that's here or there. But there's no DC offset adjustment on any of this either. Because here's your, down here, you will see this. This is for one of the channels. This is your differential pair. These are your emitters that tie together. Here's your 33K that comes off your power rail, goes into here. 33K in the middle. There's your emitter, collector, base. Okay, there's no DC offset adjustment in this whole thing. And so I haven't even powered this thing up yet, and I'm at the point where it's like I don't even want to power it up because all these collectors are shorted to the heatsink. So now I gotta go and isolate all these, and hopefully the mica insulators on the back of this heatsink, on the back of the transistors. See, that one shows open. And this one here, there we go, heatsink. That's a heatsink. There we go. Look at that. It just keeps climbing up. You can't really see that on the screen. And you can see the cap charging up, and it'll let go, but that's here nor there. But here we go. Like, this is in the back of the heatsink on every single collector. Oh, there's a dead short right there. Oh, it's cap charging up, but still, there shouldn't be no continuity between there at all. Zero, absolutely zero. Should be 100% isolated. Whether it's a voltage regulator over here causing the short, maybe because it's just up against it. It goes through a cap too, but regardless, if the output stages are isolated from the heatsink, it's not going to matter. That's a dead short right there. There you go. That's probably where all that's coming from. But still, regardless of that. Anyway, so what I'm going to do here now is move that out of the way. I'm going to show you the side of the heatsink right here. You can see it's been damaged. It's been hit. And there's an indication in the box itself that it was hit. And if you see the gap here, you'll see the gap here on the side of the circuit board, and you'll see the gap over on this side circuit board there and there. They don't match. And if you look straight down here on these transistors, if you look down on here on the output stage down here, you'll see that they're all been shoved over. I'm hoping the mica insulators are okay, but what's happened is this thing's been shoved over this way. It's been hit. And not only that, this got hit that way and broke. So it's been damaged here, and then this thing got damaged this way in shipping. Anyway, so that's going to be fixed eventually. We'll figure that out. It's got some good polyester caps in here. A nice little electrolytics. Not the greatest, but they'll work. It's got a nice diode rectifier there. It's good for 52,000 volts at input surge of about 200 amps at 8.3 milliseconds, microseconds. It's about a half a sine wave, so that instantaneous, surge current that charges your caps. It's about 4 amps. It's rated for 4 amps. This thing's only rated around 3, but these transistors will do much more than that. They're good for 8 amps. They'll never see that. This heatsink's not near good enough for that. Yeah, so I will keep you updated on that one. I had to do a lot of straightening of components on this thing. It was just terrible. As you can see, some of the layout here, you get the power rails coming over here underneath the op amp. I don't really like that. It's kind of stupid, but This is going to get changed out eventually. It's going to get thrown onto a back. It's going to be put into a case eventually and fixed up. This is for my girl, so I'm going to build this up for her computer system. And this here, as you can see, look down on here. This comes off the positive side of the diode rectifier, and it comes straight across here. And this is a jumper wire that comes over here. You can see it right there. This is the positive side. It comes over, jumps over the side of the board here and over to there. Only thing I don't like, if you see it right here, the capacitor right there, and this capacitor right there, the case is touching that. So yeah, I'm not overly a fan of that. So we might do something about that as well. Take that jumper there probably, and either move these caps over a little bit if I can. Maybe not, but we're definitely going to try to see if I can isolate those a little bit better. And yeah, these standoffs I just made. I made these out of an old set of computer speakers. Took the posts out of it, screwed them on so they weren't sitting down there. When you're trying to do these things budget-wise, like this amp kit only costed, what, 30 bucks. You can't buy these, you can't buy the components and heatsink and transistors and resistors for that to even build one. So when you do stuff like this, you have to be able to go through it, measure all your components, make sure there's no short circuits like there is right here. If I would have hooked this up, this thing would have grenaded, and the dim bulb would have lit up like a Christmas tree for sure. So, alright, I'll keep you informed, and I'm going to go ahead and isolate these, and then I'll let you know what I did for that. Alright, take it easy, thanks for watching.